So obviously the vast majority of what you would need in a new frontier country like America is surveying, because farmers need to know how big their fields are. They need to know where boundaries are. Things like the Mason-Dixon line, that all comes about in the 18th century. So map making is incredibly important. Now, very often you wouldn't see these very large, grandiose maps, because these would be done by the government. The Corps of Engineers at that time is going to do the larger ones. However, you do have civilians knocking out, just like we said, plots of land in important parts here in South Carolina. Large landowning families, obviously, are making their money off of cash crops, things of that nature. And so these are reproductions of two original ones. Something kind of interesting to think about. Sometimes you don't think about the mechanics of it. Maps, really big, long, large, rolled up things. How are you going to carry all that around with you on horseback? It's not convenient when you're trying to survey in the middle of a forest. So what they did was they would literally put linen backings and glue them to the maps, cut the maps into squares, and then you could fold everything up, but you're not going to damage the highly fragile paper because you have already glued it to this linen backing. Something that they were doing with military maps right on up through World War I. Just a little interesting tidbit there. So some of the most basic ways to survey, well, first thing you gotta do is measure distance, right? And how do you do that in the 18th century? Well, there's not a lot of standardization. There's some, but not like today. So your main way of measuring is to drag what we call chains around. And if you've ever seen the old deeds from this time period, going right on up through the early 20th century, believe it or not, you hear the terms chains and links and rods and things of that nature. Well, these are original chains. And as we said, in terms of standardization, sometimes there's a little bit of variation there. Now these chains, each link is 1 foot. And you have 100 links in a chain, so go figure, 100 feet. Every 10 feet, you have a little tally marker here. I don't know if that's going to come through or not in the video, but the tally marker has got 3 hashes in it, which means that's my 30 link mark. So as we're dragging these around and measuring distances, it's a faster way. You say, I see my 30 hash link, I guess I'm at 30 feet. So these are specifically called engineering chains because military engineers like to use 1 foot increments. What do we have over here, however? Something called Gunters Chain. Now, Gunters chains were favored by civilian surveyors, and each link in a Gunters chain is 7.92 inches. Isn't that great? 7.92, yeah. But a 100 link full Gunters chain is 66 feet. Now we say, who cares, right? But 10, it's going to make sense here in a second. 10 square chains is an acre. So civilians want to use Gunters chains. And so if you look at your old deeds and everything, and they're referencing chains and links, it's more than likely Gunters. Now, the other neat thing about a Gunters chain is it's divisible by a lot of the other common measuring devices of the day. We mentioned rods. There's 18.5 feet in a rod. So rods go evenly into a Gunters chain. There's 6 feet in a fathom. You've heard of fathoms before. Well, there's 11 fathoms in a Gunters chain. So it all sort of starts to make sense to a certain degree. But that's why they came up with the sizing that they did on that. And these maps were not catch-as-catch-can rudimentary guesswork. These guys were very skilled. They knew about magnetic declination. They knew that depending on where you were in the state, that there could be deviations in your mathematic measurements. They had land-based octants or sextants, and most people usually consider that something you use for navigating by the stars at sea. But you could still do that over long distances, over several hundred miles. You have an artificial horizon, believe it or not, that they would look through to tell what's flat or what's even and level, and then they could shoot up and look at the stars. And that's basically how they did the Mason-Dixon line, because they're going over such a large distance. You've got to have some means of long-distance navigation. So that's just a brief overview of some of the most basic measuring things. Now we can start to talk about some of the equipment that they had.